Section 5.3, Area. In this section, we're going to be talking about the concept of area and then using formulas to find the area of 5 different polygons. A few things we need to note before we start working through examples is some notation that we're going to use. In triangles and other figures that we talk about, many times we use the letter H to represent the height of the figure. The height is also called the altitude, and the altitude is always drawn perpendicular or at a 90-degree angle to the base or bases, sometimes when you have more than one. Now let's look at some formulas for areas. You may recall these from geometry. If not, they're pretty easy to remember. So if I look at my first shape, I have a triangle. To find the area of a triangle, we will do 1/2 the base times the height. For a rectangle, we take the length times the width to get the area. Since a square is a rectangle, we actually could use the same formula that we use for rectangles and do length times width, but what happens is the length and the width are the same amount. They're both S. So that's why our formula turns out to be area equals side squared. A parallelogram is very similar to a rectangle, but you can think of it as a rectangle that's kind of been slanted. So what I'm going to do to find the area of a parallelogram, just like with a rectangle, where I multiply length times width, we call those same units the base and the height. So its area is base times height. And then in a trapezoid, to find the area of a trapezoid, we're going to do 1/2 the height, or the altitude, times the sum of the two bases. Now the bases are my two parallel sides. So here at side C and side B would be my two bases. In example 1, we're going to find the area of a triangle. Well, we know that our formula for area of a triangle is 1/2 base times height. Now substituting in that the base is 10 and the height is 4, we find that our area is going to be 20. Now we need to put on our units, and our units will be square inches, because this is really 1/2 10 inches times 4 inches, and inches times inches is square inches, or inches squared. Now let's find the area of a trapezoid that has an altitude or a height of 6, and the parallel sides, which we also call the bases, are 12 and 24. So our formula is 1/2 the altitude times the sum of the bases. The altitude is 6, and my two bases are 12 and 24. Now you may want to use a calculator for that computation. So that's going to give you an area of 108 square inches. Now we're actually going to combine some figures and make a composite figure and compute the area of it. So if you notice, what we have here is we have a rectangle, and then we have two triangles that are attached to it. So here's one of our triangles. And then we also have this triangle. So I'm going to find the area of each one of those shapes individually. So let's start with our rectangle. Well, we know the formula for that is length times width. So that will be 2 times 3, which is 6. Now let's find the area of the triangle that's kind of sitting on the top here. So we know the formula for that is 1/2 base times height, but the base of this rectangle is equal to this distance here. So then we'll know that that is 3 and our height is 2. So that's going to give me an area of 3. And then lastly, we'll compute the area of this triangle, which again, my formula is 1/2 base times height. And our base is this distance, which corresponds to this distance of 2 on my rectangle. And my height is 1, so that's going to give me 1. Now, once I know all three of the areas, to get the total area, all I'm going to need to do is just add those together. So that's going to give me 10, and we were measuring in centimeters, so it will be square centimeters. Example 4 has us finding the area of a rectangle with a square cut out of it. So we're looking for this enclosed orange area. And what we can do to find that is just find the area of our larger outside rectangle and subtract out the area of the square. So the area of our rectangle we know to be length times width. Well, that's 30 times 25. That's 750. And then our square has an area that's s squared. So that's 10 squared, which is 100. So then we can find our total area. We'll label that as the orange area. Would be 750 minus 100, which would be 650, and we were measuring in feet, so that will be square feet. In example 5, we're going to find the area of this given polygon, and we're actually going to look at this two different ways. One is to do something we did earlier, where we're going to consider this to be like a composite figure. We'll draw a line straight across here. And when I do that, I've now divided this up into 3 rectangles. And what I'll do is I'll just compute the area of each one of the rectangles, and then I'll add them together. So if I look at rectangle 1, it's a rectangle whose formula for area is length times width. So it's 2 by, then I have to find this distance. Well, 8 is the entire distance. So I need to know how much is this part. But that would be the same amount as this side of 5 that I've got marked for rectangle 2. So this first rectangle is a 2 by 5, which would be 10. Rectangle 2 is a 5 by 6, which would be 30. And then rectangle 3 is 12 by, we need to know this distance. Well, by using back what we did with rectangle 1, that first part is 5, we know that this bottom section has to be 3, so that the total distance on your left-hand side will be 8. So rectangle 3 is a 12 by 3, which is 36. Now if I add those two together, I get a total area of 76. So that's going to be method 1. Now, another way I can do this is rather than do it by adding areas, I can actually also do this problem by subtracting areas. And what I can do is think of this as one big rectangle with this smaller rectangle cut out of it. So I can do this problem as a subtraction problem. So let's look at the area. This will be method 2. What we'll see is we get the same area. So if I do the large rectangle, my large area is 12 by 8, which is 96. Then I have that inner rectangle, which is a 5 by 4, which is 20. And now in this case, what I want to do is I want to subtract the two of those to get 76. And that would be in square inches. And my units up here were also square inches. We need to mark that that was the total of 76. So guys, notice that in both of these examples, or in both of these methods, we get the same area of 76 square inches. But in this case, method 2 is much quicker and easier to visualize, I think, than to do it by method 1. But both methods are correct. In our last example, we're going to find the perimeter and the area of a baseball infield. So we're told that it is in the shape of a square with 90 feet on each side. So I'm going to kind of just make it look the way it would look on a baseball field. So here would be home plate. There's first, second, and third. So what we're told is that each of the sides are 90. So we want to know what's the perimeter of the infield and what's the area of the infield. Now we need to know our units. This is 90 feet. So remember that for a square, to find perimeter, we do 4 times our side. But 4 times 90 would be 360. And that's feet because we'd add up 90 feet 4 times. And my units would stay feet. For B part, we're going to find the area of the infield. Well, our formula for the area of a square is just side squared. Well, our side is 90, and when I square 90, I get 8,100, and this time my units will be square feet, because this would be multiplying feet times feet, which would give me square feet. We're now to the point in the video where you should pause the video and then work out the practice problems so that you can check them. Again, make sure you show your work on your note sheet so that you can turn those in as your notebook. And then if you get any answers incorrect, we'll discuss them in class, the next class meeting. So pause the video and look and work through your first 2 problems. Now that you're finished with those 2 problems, here are 2 additional problems. And one of the things I would suggest is that you would go ahead and draw a picture that corresponds to these, since no picture is given to you. Don't worry about trying to draw to scale. Just draw something so that you have a rough sketch to go by to help you visualize what the problem's asking and what you're looking for. Now that you've had time to work through all the problems, here are the correct answers. Again, if you don't have an answer correct, just make note of which ones you've missed, and then when we get to class in the next class period, you can just ask about those problems and we'll discuss them.